This is Jacob, and Jacob, well, he'd like you to know that he has some very elaborate plans for your front yard. Jacob is an engineer specializing in geothermal energy systems that use the energy that's trapped below the Earth's surface. No matter how far you go into our past, you will find humans using geothermal energy, and Jacob is convinced that the same can be said of our future. We met Jacob at the site of one of his earliest geothermal systems, tucked away in a secluded valley, to discuss digging holes and advocating for a technology that, even though you can't see it, is already all around us, here on Renewable.
We move heat from the ground and we upgrade it with magic and we put it inside the building. I mean, I can give you the detailed answer of how a refrigeration cycle works, but magic just is easier. My name is Jacob Komar. I own a firm called Revolve Engineering. We specialize in energy consulting, net zero buildings, and geothermal system design. So this is the Alfred H. Savage Center. It's essentially an amenities building. It's used for all kinds of events, recreational programs, summer programs, retirement parties, weddings. This building has no gas line connection to it. We don't need it. One of the disadvantages of geo is that it's hidden. And nobody walks by this building and realizes that it has a ground loop heat exchanger. A solar system is very visible. So you don't realize that there's double the amount of geo installs in the province than there's solar installs, right? So it's easy to say something doesn't work when you never see it.
So if we can't see it, how does it work? Below the center, there are boreholes, each going down about 200 feet. And they have to go that deep because they need to reach the point where the ground temperature levels out, where it doesn't matter if it's a hot Alberta summer or a freezing Alberta winter. The ground is basically the same temperature.
The ground is constant. So it doesn't matter if it's minus 40 outside, my ground temperature is 7 degrees. So that's a stable source. So that's why the efficiencies are higher than any system. And that's what drew me to it. It's the most efficient way to heat and cool a building, bar none.
What GeoExchange does is it collects that energy that's trapped below the surface, and it uses it to either heat or cool your home. As the glycol runs through the pipes, it warms up to the ground temperature around it. But that temperature, which is about 7 degrees, isn't warm enough to heat a building with. This is where the heat pump comes in. The heat pump concentrates the heat from the system, making it warm enough to heat an entire building. It can also run in reverse to cool the building down. As Jacob said earlier, it might seem like magic, but it works. And since the heat pump that moves all that energy around runs on normal electricity and not on natural gas, that means that GeoExchange essentially electrifies your house in the same way that you can electrify a car. As the electricity grid gets cleaner, your house runs cleaner too.
It lasts for hundreds of years. Like, you put it in the ground, and that's the worst part of plastic, but in this case, it helps us because it's there for hundreds of years and you're never gonna have to replace it. Obviously, the heat pumps in the building will need replacing, but that's one of the huge advantages is it's there essentially forever. It'll outlast the building.
We asked Jacob to crunch the numbers for us, and him being an engineer, he readily obliged.
Let's say your home uses 100 units of energy. 15 is electricity, 85 is natural gas. You do nothing else but attach a geosystem to cover off your space heating and hot water in your home. You took that 85 units of energy and you reduced it to something like 20. So now instead of 100, now your home's using 35, right? So bang for buck, you get way more for energy efficiency, in this case geo, just because of the efficiency. I'm 5 times as efficient as a traditional boiler or furnace.
Which raises 2 questions. The first, what exactly are you installing in my house?
You'll run plastic piping into your basement You'll replace your furnace with a heat pump. They look identical. If you were standing beside a heat pump versus furnace, you wouldn't be able to tell the difference. It's got a fan, a blower, so you connect it to your existing ductwork. So practically speaking, inside your home, except for your basement, you wouldn't have to touch anything.
And the second question this all raises, I guess more of a statement actually, is it sounds like you want to dig a bunch of holes in my yard. Is that an easy sell, and is it a good thing?
It's huge and exciting because if we think about it, the one expertise we have in Alberta is drillers. We know how to drill boreholes in this province. And we need a lot of boreholes drilled in this province for geo. And the amount of homes and the amount of buildings that we need to convert to electricity and renewable-based systems is mind-blowing. So we have a huge task ahead of us, but we're very well positioned in the province because we have all that expertise.
With an energy source as old as geo, it's easy to only ever talk about its past. But it's the job of Jacob and engineers and entrepreneurs like him to get us thinking about its future again. We wrapped up with him with a question to that effect. How do you convince people that the energy beneath our feet, energy we've been using since antiquity, is the future?
A geosystem is more comfortable, lasts for hundreds of years, reduces your energy use by 80%, which reduces your energy bills, which reduces your future energy risks. Let's start looking at the positives and the exciting things. So we need to embrace this challenge and lead in this, right? We still need petroleum right now. We still need oil. We still need these industries, but to rely on them forever, I think is folly. I think we need to transition as quickly as possible because we don't want to be left behind.